Hello everyone, I am Dr. M. Velumani, Assistant Professor, Department of Civil Engineering. Today we are going to discuss a very important topic in types of column and footings. These are the list of content, introduction, function of columns, classification of columns, column based shape, column based reinforcement, column based loading, column based slenderness, function of footings, classification of footings, isolated footings, combined footings. Introduction to column and footings. Column and footings are two essential components of reinforced concrete structure. Column are vertical load bearing member that carry a axial load as well as bending moment, transferring this force safety down to the foundation. Footings act as a base support, separating the load over large soil area to prevent the settlement or failure. Together, they work as an integrated system where the failure of either cases of collapse. IS 456 provide the classification and design rules and correct the selection ensure the both safety and economy. Function of columns. Column as the backbone of RCC frames. They primarily carry axial compression loads but also resist the uniaxial or biaxial bending moment depending on the loading conditions. Their role is to provide the vertical support to substructure and transfer load to the foundation. They also help maintain the over stability against the lateral force like wind and earthquake. By forming the rigid formwork with the beams and slabs, column prevent the excuse deflection and buckling, especially in seismic zones. Tactile in columns is virtual. Classification of columns as per IS 456. According to IS 456, column can be classified into multi ways. They may be based on cross section, shape, reinforced types, loading condition, slenderness ratio, or method of construction. Another key between the short and long columns. Depending on the slenderness, structurally column may be tied, spherical, or composite, and functionally they can be gravity column or lateral load resisting column. Each classification influences the strength, ductility, and failure mode of the column. Column based on shape. The shape of a column's cross section significantly affect its performance. Rectangular and square column are most commonly in building because they are simple to construction and easy to reinforce. Circular column are preferred in piles and bridges due to their uniform strength in the biaxial bending and aesthetic appeal. Polygon shape are the sometimes adapted for the architectural requirements, while rectangular section are easy to shudder. Circular ones offer better buckling resistance. The shape selection depends on both the structural and architectural needs. Column based reinforcement. Reinforcement arrangement in another important classifications. Tied column consists of the longitudinal bars held together by the lateral ties and are economical wide used. Spherical column reinforced with helical reinforcement provide the greater ductility and higher load capacity, making them safer in seismic zones. Composite columns combine the concrete with structural steel, offering an excellent strength and stiffness, especially in bridges and high-rise buildings. The types of reinforcement covers the not just the load capacity but also the mode of failure. Spherical column failure gradually, will tight column of failure suddenly. Column based on loading. Column may also be classified based on the loading. Actually, loaded column carry pure compression, but in reality, such ideal cases are rare. More common are uniaxial or biaxial eccentrical load columns, where the load is offset from the centroid. Introducing the bending, biaxial load is often seen in corner and interior column of a buildings. Design as such a column use the interaction curves from IS 456, requiring the more reinforcement to ensure the ductility and stability under combined stresses. Column based on slenderness. Slenderness ratio plays the critical role in column behavior. Short column where the effective length to least radius of gyration is the less than 12 generally fail by crushing. Long column with the ratio greater than 12 fail by buckling. The buckling load depends on the effective length and the end condition. In practice, short columns are more common, but long columns appear in tall structure and towers. IS 456 specified the effective length factor to help account to end condition in design. Function of footings. Footings ensure that the load from column and walls are safely transferred to the soil. Their primary role is to spread in the load over the large area, keeping the contact pressure within the safe bearing capacity of soil. They also help prevent settlement and maintain the structure stability. A well designed footing protect the superstructure from soil related problem, resistance cracking, and ensure the long term durability against moisture and chemicals. These footings are the footings are this based on the safe and economical foundation systems. Classification of footings. Footings can be classified in a different way based on support. They may be wall footing or column footing. Based on the shape, they include the isolated, combined, raft and pile footing. Plain concrete footing are used in the light loads, while RCC footing are used in the heavier load. Depends on the soil load, there may be shallow or deep foundation. IS 456 specifically classified RCC footing and gives the design provisions. The choice depends on the both the safety and the economy. Isolated footing. Isolated footing are the simplest and most widely used. They can square, rectangular, circular in plan and are the highly economical where the soil is good bearing capacity. The load is there transfer the uniform the soil with the reinforcement provide the both direction to resist the bending and shear. The thickness of covered by the shear strength and proper detailing prevent the cracking. These footing are very common in residential and low rise construction. Combined footing. Combined footing is the supported two or more column, especially when the column are closely spaced or near boundaries. There may be rectangular trapezoidal in plan and distributed in load in evenly between the columns. Raft and pile footing. Raft or pile footing is the large slab supporting multiple column or entire building. They are particularly useful when the soil has a low bearing capacity as they are minimized different settlement. Raft are commonly used in basement, water tank and industrial building. Pile footing foundation by concentrated the deep system where the load is transferred in the deeper hard stratum through the piles. They are used in the bridge, towers and high rise building and may work end bearing or friction piles depending on the soil conditions. Thank you for watching this lecture.